Welcome back to the next concept under graphs and transformations. We are on our second last concept as of right now, where I'm filming this. And it's going to be talking about the variations of graphs. Okay, so I want to first clear things up. There's a difference between transformation of graphs and variations of graphs. Okay, I want to first clarify. Earlier on in the past few fundamental concept videos, we have been talking a lot about transformation, right? Transformation comes in the form of 1, 2, 3. Translation, scaling, reflection. The purpose of all these three, right, is to change one graph into another new graph. Okay, we are going from one graph to a brand new graph, a second graph. But now, under this thing called the variation of graphs, we are going to introduce two more concepts. One is called modulus. The second one is called reciprocal. So this one is also going from one graph into another new graph, right? But the thing is that this new graph is completely different from the original graph. Completely different. Okay, so I will just put a completely different graph. So if it helps you in your revision later on, you can just revise all these 5 concepts together. But there's a slight difference between these two. One is transformation, where you take your original graph, you pull it, you scale it, you reflect it whatsoever to get a new graph. Whereas for variation, it's just one application. You either modulus it or you reciprocal it, and you get a completely new graph. Right, so that's the whole concept behind it. We are going to be talking about the modulus function first. Then after that, we'll go into the reciprocal function for this graph. Okay, for the variation of graphs. So what exactly is the modulus of a function? First, let's talk about what modulus actually stands for. And a lot of JC students, when they read this concept at the start, they tend to not understand it fully, and as a result, it comes back and haunt them later on in the later chapters when the concept of modulus appears again. Not only just in graphs, but this concept actually can appear in many places. So let's talk about what modulus is first. Okay, now modulus is all about just measuring the distance from 0. Okay, that's the very generic meaning of modulus. So when I have a number line, okay, I'm just going to draw a number line over here, for example. Let's say here is 0. 1, 2, 3, -1, -2, -3. So when I have, let's say, a point over here, right? The distance from this point to 0 is 1 unit, right? That's why when we take modulus 1, right, the 2 bars over there, it means modulus. Like these 2 bars over here. Modulus 1 has a value of 1 because the distance from 1 to 0 is 1 unit. Let's say I have another point over here. Okay, I'm just going to maybe draw a different shape. Let me draw a star. The distance from -1 to 0 is also 1 unit. Therefore, modulus -1 is also 1. Not because we remove the negative sign and that's it. What actually goes on underneath the hood is that we are trying to find out what's the distance from 0. And just nice is as simple as just visually removing the negative sign. Okay, but you need to know what goes on beneath the hood to really appreciate this concept. That's why when we say modulus -2 is just 2, right? Because the distance from here to 0 is 2 units. So that is the whole meaning of modulus. And with that said, right, let me now zoom in and sketch a graph for you to see. So let's say originally I have a graph over here. And let's say my graph is originally like that. This is y equals to fx. So there are 2 different variations of y equals to fx. Y equals to fx, right? We can modulus 2 things. We can modulus the y value, right? We can modulus the entire y value. And in the end, we get y equals to modulus fx. We can modulus the whole entire thing. Alternatively, what we can do is that we can also modulus just the x value, modulus x value. And what we end up with is y equals to f modulus x, like that. So 2 ways or 2 variations that stems out from the original graph. But how would it look like in terms of graph drawing. So using this concept over here, right, understanding that modulus is just measuring the distance from 0. If we, let's say, modulus y, and then let's say we assign a value over here, right? Let's say this value over here is 3 at this point over here. When we have 3, right, and then we modulus 3, it turns out to be 3, right? So therefore, the graph, the modulus graph, it will still have the 3 inside. It's not affected by it, right? And then let's say at this point over here, this corresponding value is 0, right? When we have 0, and then we modulus 0, we still get 0. So the graph is not affected. But then let's say at this point over here, let's say this is -2. This y value over here is -2. Remember, because this is the y-axis and then this is the x-axis. So for a y value to be -2, the original value is -2. And then now I modulus it. What is the value that you expect to come out? You will expect the value of 2 to come out, because modulus -2, as what I mentioned earlier, it's not because I just remove the negative sign like that. It's because modulus is all about measuring the distance from 0. So when I modulus -2, the distance from -2 to 0 is 2 units. And that's why the final value that comes out is 2 units. So the graph for modulus will therefore look like that. I'm going to use a different color. Hopefully it's a little bit clearer. Maybe I draw it a little bit thicker as well, so it's more obvious. Okay. It comes down, touches 0, reflects up, comes down, and then it goes back up again. Right? Whereby here now, this is +2. And then this graph is modulus f x over here. Right? Because you see that for this point here and this point here, now -2 will become 2 under this new graph over here. So in short, for this type of questions, you don't need to describe. So for just note that for variations, rarely do they get you to describe. For variation of modulus or reciprocal graphs, they usually just get you to sketch the graph. So this one, you just need to remember, you keep the top, you flip up the bottom. Anything in the positive y-axis is not affected, because when you modulus the positive value, you get back the same value. Whereas anything in the negative y-axis, when you modulus it, you get the positive value. So in essence, you flip it opposite the x-axis. Okay, now let's talk about the modulus x. Let's say I have, I'm just going to, add a few more details to the graph. Okay, so let's say I add this detail here, and then let's say I add this detail here. Okay, so my green color graph will also look like that. Then my green color graph will also look like that as well. I'm just going to erase this portion here as well. Erase here, then my green color portion now will look like that. Right? Okay, so for modulus x, at this point over here, x equals to 1. And when I modulus 1, I get back 1. So no change. At this point over here, this is 0. When I modulus 0, I get back 0. So no change. Right? But then let's say at this point over here, or rather, let me draw a more clearer example. Let's say this point over here. Let's say this is -10. When I modulus -10, I'll get +10, because the distance from -10 to 0 is 10 units. Right? I'll get 10. So if let's say, when I transform this graph to this graph over here, let's say originally is y equals to f10. And now I transform it to, -10, right? -10. And then now I transform it to modulus -10, which in the end will give me y equals to f10, right? Because when I modulus the negative value, what comes out is the positive value. So if y equals to function of -10 now becomes function of 10, that means whatever is going to appear over here would be the mirror reflection over here. In other words, the original point over here, at this point over here, which is f-10, now it will become f10 instead. Because -10, I mod it, I get f10. So the position of f bracket -10 will now become f10 instead. So a very easy way for you to remember this concept, I'm just going to write down the shortcut here for you to remember as well, would be to keep everything on the right of the y-axis, because anything on the right of the y-axis all have a positive x value, and reflect the right onto the left. So what that means is I will keep everything on the right over here, and then I will reflect the right onto the left. So now it looks like this, whereby here now this portion is a mirror reflection of here instead. And this black color graph will now be modulus X over here, because we are just replacing every single original value over here with the value on the right, because of the reason that I mentioned earlier. Okay, so for modulus, these are the two variations that can happen to a graph. And that's why I say we transform it to a brand new, completely different graph, because you can see that they all look very different, right? So variation, you can think of it as a much more drastic change compared to just transformation. Okay, so this concept might take a little bit time to get used to it, but just like with everything else in math, the more you do it, the better you get at it. The more you do it, the more familiar it gets with you. Okay, so that's it for this. We're going to try out the example question over here right now. Feel free to pause this video to actually tackle this question. Try to tackle this question, try to sketch it for yourself. And when you're ready, come back and let's go through the answer for this together. All right, so let's go through the answers for this together. If you found it challenging, it's okay. The first few times it's going to be hard, but you know, it gets better. So our original graph looks like that. And I'm just going to draw it directly over here. Okay. And then we know that the critical points are given over here. A, right? We are given the asymptotes, the horizontal asymptote, the vertical asymptote as well. So we are now required to draw the modulus of y equals to modulus of x. So what this means is that every single y value now becomes positive. So remember earlier on when I say the first kind would be when you modulus the whole thing, the shortcut to remember would be to keep the top and then you flip up the bottom. Okay, but when we sketch this, we need to sketch it with a bit better precision, which means that we should also sketch it with the asymptotes as well. So if you're going to flip everything up, right, from bottom flip up, the vertical asymptote of x equals to 1 is not affected, right, because you're just flipping things upwards. The x equals to 1 doesn't change. And then the original asymptote here of y equals to 2 is also not affected because you're just flipping it up, right? The y equals to 2 originally is positive to begin with. So if you just modulus a 2, it will still be 2. So it's not affected. And everything that was originally above is also not affected. So what we can do is that we can just go and sketch this first and make sure that our graph is accurate. Okay, I'm just going to use a different color here. So from here, I come down, then I go up, and then I shoot upwards. Right, from here, I shoot upwards like that. Right, and here originally is the A, and originally here is the B. Right, but now my bottom graph over here will now need to flip upwards. So when I flip it upwards, it will look like this. Right, because now I'm flipping it upwards. And therefore, this is the answer over here, right? It's as simple as that. So just know that for modulus style questions, they typically will just require you to sketch it and there's not much explanation to be done, unlike transformation. Okay, if not, that's it. That comes to the end of this concept over here. And if you have no other questions, you can feel free to head on to the next one and I'll see you in the next portion.